Okay, this is part 2 of lesson 6.1, and it's determining angular velocity. So here's the question. It says the London Eye Ferris wheel has a diameter of 135 meters and completes one revolution every 30 minutes. A asks us to determine the angular velocity in radians per second. The fact that they tell you that the units are radians per second tells you how to calculate the angular velocity. Per is divide. So what we're going to do is we're going to take our radians and divide it by our seconds. Or specifically, to find angular velocity, we're going to take our angle and divide it by our time. And the key is that we want our angle in radians and our time in seconds. So to find our angular velocity, we need to figure out two things. An angle related to a time. So we have to look in our question to see if they tell us anything about any angle in radians related to any time. And the key to the question is this piece right here, even though there's a typo. One revolution every 30 minutes. One revolution means one complete turn. How many radians is one complete turn? Well, one complete turn in degrees is 360 degrees, so how many radians is 360 degrees? And we learned previously that one complete revolution or one complete turn is 2 pi radians. So now we know our angle. We've rotated one complete turn, or 2 pi radians. How long did that take? Well, it took 30 minutes. Unfortunately, we want time in seconds, so we have to convert. To convert, we multiply by the units we want, which are seconds. How many seconds are in a minute? Well, in 1 minute, there are 60 seconds. And that's how you convert. Multiply by what you want over what you have, and you always relate it to one of the bigger. 1 minute is 60 seconds. 30 times 60 is 1800 seconds. So we have our time. Whoa, nice line. We have our time and we have our angle. So if we want our angular velocity, we've got our angle divided by our time. And to simplify that, it's pi over 900. And to make that a decimal, that's approximately equal to 0.00349 radians per second. And again, radians aren't a unit, but it's nice to relate it to something, or radians per second. B says, how far has the rider traveled at 10 minutes into the ride? So we want to find the arc length that this rider travels, and we can do that by using the equation we used that defined what a radian was, and that was that the angle equals A over R. So what we need to do is we need to figure out what angle they traveled given a radius, so we can rearrange and solve for the arc length, or how far the rider traveled. So we want to rearrange this, multiply both sides by R. We get that the arc length is the angle times R. Well, what's the angle? The angle is found by figuring out how much or how far we've rotated. Well, 10 minutes into the ride is 1/3 of 30 minutes. So we've traveled 1/3 of the way around a circle. Well, if the whole circle is 2 pi, 1/3 of 2 pi would be, well, 2 pi over 3, or 1/3 of 2 pi. And the radius of this circle is diameter divided by 2. The diameter is 135. Divide that by 2. You get 67.5 meters. So it's 2 pi over 3 times 67.5 meters. And that will help you find your distance. And in this case, our distance, or our arc length, is 141.4 meters. So if we want a distance traveled around a circle, that's our arc length. We need our angle and our radius. Our angle comes from what proportion of the circle we've gone around. Whole circle is 2 pi. 10 minutes is a third of 30 minutes, so a third of 2 pi is your angle, 2 pi over 3. And 67.5 is your radius. Multiply the two and you get a arc length. Same units as a radius, so it's 141 meters. That's an example of how you can use the definition of an angle in radians to solve for an arc length. And it's how we can use radians to find angular velocity. Thanks for watching, and I'll see you in lesson 2.